Hello and thank you for watching this video about implementing a coding activity into your classroom that is based around the requirements of version 9 of the Digital Technologies curriculum. This activity discussed in this presentation is a maze escape game that has been designed to be implemented by a Year 5 class and looks to satisfy the curriculum requirements of AC9 TDI 6P02, design algorithms involving multiple alternatives and iterations, and AC9 TDI 6P05, where students are required to implement algorithms as visual programs involving control structures, variables, and inputs. Students will be required to build their maze escape game through Scratch, which is a free block-based programming tool that helps students of all ages and experience levels learn how to code. Scratch utilizes a graphical interface where users can simply drag and drop multicolored blocks which represent different programming commands, rather than having to learn the often difficult process of writing outlines of code. Enjoyed by 133.5 million registered users, Scratch is a fun and interactive way for students to not only learn essential coding concepts such as sequencing, loops, and conditions, but also express themselves creatively in a safe online environment. This activity was developed with consideration to Chandra and Lloyd's 5-step process model, which looks to develop conceptual understanding of coding and computational thinking with and without the use of technology. Step 1 and 2 of the model looks at teaching concepts without the use of technology, and in regards to this activity, would take place in the lessons leading up to this activity so that students' conceptual knowledge of what elements make up a maze is at a level of readiness to partake in the maze building activity. Step 1 of the model is to introduce concepts through play and games. Students will be presented with various maze-based toys in which they can interact with individually or collaboratively, such as marble mazes and marble runs. Step 2 of the process is to build concepts with physical actions and objects. Pairs of students will participate in a blindfolded maze challenge, where a blindfolded student will rely on their teammates' instructions to successfully draw their way through a maze. Step 3 is to play and connect concepts with software. During this stage, a teacher would take on an I do, we do, you do learning approach to introduce the maze escape activity. Students will be required to firstly watch their teacher work through the following steps. Students will be shown that they need to select a sprite as their main character for their maze, in this instance, a beetle. They'll also be shown the technique to resize their sprite. Students will be then directed to create the first level of their maze by selecting the stage button in the bottom right corner and clicking on Backdrop tab at the top left. When this opens, students will be directed to use a rectangle tool to make the shapes for their maze design, making sure that they include an exit location to end their game. Next, students will be shown how to get their sprite to move. This is done by making sure our sprite is selected and then clicking on the code tab in the top left corner. In the motion category, drag out the move step block. If we click it, our sprite will move. However, in order to gain control of the sprite with the directional keys on our keyboard, the following algorithm will need to be created. On top of the move 10-step blocks, we will attach the point in direction block and change the number to 180. This will allow our sprite to go downwards. And we also need to include the when space key press block and change the spacebar to downward arrow from the drop-down menu. Repeat these steps until all directional paths have been created. Our sprite can now move in all directions. However, we have our first debugging issue to tackle. How can we stop our sprite being able to walk through walls? To do this, we'll go to the sensing category and select the touching color block. Change the color on the block using the eyedropper tool to select the color of the walls. We'll need to incorporate our if-then block at this time to tell the sprite if it touches the color of our wall, then walk back 10 steps. Include a when green flag tick button on top of this to test our sequence. Upon testing, you can still walk through a wall. To fix this, a forever block needs to be placed around the algorithm in order for Scratch to remember to always use this rule. Now when you test, the sprite can't walk through walls. Once our sprite is able to move around, students will be able to quickly evaluate and rectify any issues occurring with their maze design. For example, our sprite is too big to fit through the path. Once the above steps have been completed, step 4 of the process model will begin, which is practicing with examples. During this stage, a we-do learning style will be implemented in which the teacher will go through the instructions presented before, but this time students will be required to follow along on their own devices. At the end of this example activity, students will be given time to make their own modifications to the project to assist in the facilitation of new knowledge and confidence development. For example, they could add more maze components or change the background color to a source image. And finally, step 5 of the process, in which students create design solutions, will take place following the you-do learning style, in which students will implement what they have learned in the previous stage to continue creating the other levels of their maze game with little to no teacher intervention. As you can see, this activity will give students ample opportunity to not only work on their coding abilities, but also their computational thinking by helping students understand the idea of decomposition by requiring them to break down their maze requirements into smaller to-do tasks such as what will my sprite be? How will it move? What style of path am I going to use? Will my game have obstacles? Students will experience the idea of pattern recognition by reviewing their maze levels to see if they recognize a recurring pattern in the way in which they have subconsciously designed their layouts, which might make them easy for others to crack. Students will also notice a recurring pattern in the blocks that they are used in their algorithms for each of their maze levels and may choose to use the duplicate function to promote efficiency. Through abstraction, students will learn to identify the key criteria that is required to create a maze in the real world, for example, walls, a path, start and finish locations. This activity gives students a significant opportunity to work on their strengths of writing algorithms by requiring students to problem solve and implement any other elements that they would like to include in their game, such as a time limit count or having lives or obstacles. And finally, as shown in our demonstration, there is a magnitude of issues that students will be required to debug when creating their maze game, such as sprites being able to walk through walls, not starting the correct position, or not having a code block to set forever. Thank you for listening, and I hope you enjoy implementing this activity with your class.